get to this.
Yes.
We didn't get to this quotient rule example last lesson, okay? So the question says find the equation of the tangent to the curve, okay? What are you going to use to find the equation of the tangent? Okay, the quotient rule.
Apologise. TJ misread the form. We went to everywhere across the school.
Okay.
We looked at the period one.
Okay.
Yeah.
Quickly take a seat. So we're going to use the quotient rule to differentiate. How is differentiating going to help us find the equation of the tangent? Horace? Okay, so Horace says we're going to end up using the point gradient formula. Okay. What we need for the point gradient formula is the gradient and a point. Now, people have jumped into differentiating using the quotient rule, and that's good, but I would suggest taking a bit of a step back and holding off on doing that, okay? Remember what your goal is. It's the equation of a straight line. How do you find the equation of a straight line? Using your gradient, point gradient formula, sorry. What do you need for your point gradient formula? A gradient and a point, okay? It's helpful to start with the point because there's less work involved in that. Also because we use the original equation for that, so it helps avoid confusion. What do we know so far? Okay, we know that x is 2, so we've got half a point. How are we going to find the y value?
Sub in.
Into what? So sub it into the original equation. And is that just 10?
Yeah.
Okay, so we've got the point 210. But because we set ourselves up at the beginning of the question, right, we now look and we see, hey, we still need the gradient, okay? And to find the gradient, we need to differentiate. Okay, but we've already identified that we're going to use the quotient rule, okay? So how do you start off when you're using the quotient rule? Okay, so you write down your list of U and V. Now, you're going to have your quotient rule on your formula sheet in front of you. Okay, so this is as it appears on your formula sheet. Okay, now people have said find U and find V. Okay, so that is the first step. What's U? 5x. What's V? Okay, this is really nice, this one. What do we do now?
We then find du and dv.
Okay, so we're going to find du on dx. So we're differentiating u with respect to x, and that's equal to
5.
And then we're going to find dv on dx, which is
2x.
2x, okay? And now I'm going to write m equals, okay? Why do I sometimes write y dash equals in these questions?
If it's the normal.
If it's the normal, just to remind myself about that negative reciprocal when I get the gradient, okay? But this is the tangent, so I don't need to worry about that. I'm following my formula. V times du on dx. Make sure you've got a bracket there, okay? You might like to put the 5 out the front if you like. Minus u times dv on dx. Like we're purely substituting into a formula that we've been given. Okay? What do we do now?
Over v squared.
Oh, sorry. Yes, I actually totally... This is really important. The negative, we've got the minus in between. Okay? I didn't even finish the formula, which is actually a terrible mistake to make. Okay? You need that one for sure. Okay, what am I going to do now? Okay, expand, tidy it up. Shh, shh. So make this look better. Okay, so maybe here you're going to write this as 5x squared minus 15 minus 10x squared to save yourself a line of writing that denominator again. Okay, so I've said 5 times x squared is 5x squared. 5 times negative 3 is negative 15. Negative 5x times 2x is negative 10x squared. I'm going to simplify that, and I've got should I expand the denominator? No, if it's perfectly factorized, you want to leave it that way. Okay, although in the end, to be honest, like we don't have to tidy this up because what are we going to do now? We're going to sub in to find the gradient specifically at x equals 2. And we could have done that back here. I would usually still tidy it up, but if it was a nasty rearrangement, then just substitute. Okay, because there's no reason to do all that algebraic work if you're just going to substitute. Alrighty, so if someone's got this, that would be helpful.
How do you raise this?
Is that negative 35?
Should it be minus 5x squared minus, no, 5x squared minus 15 minus 10x?
Oh, sorry, so I put a, no? Negative 10x squared? Because the x times x?
Yes.
Yeah. And 5x squared take away 10x squared is negative 5x squared. I think we're good.
10x squared. Okay, right.
So what have we got here?
Negative 35.
Negative 35?
Yeah.
Okay, right.
Okay. So what do we do now? Boys? What do we do now?
Sub it in.
Okay, into what?
Y minus y1 equals m bracket x minus x1.
Okay, so we're going here. We've got our two pieces of information. Gradient's negative 35. The point is 210. And we're just subbing into our golden coordinate geometry formula. Okay, watch out if one of the values in the point is a negative, that you have the double negative. Okay. Okay, so this one, what am I going to do?
Just would expand 35. If it was a fraction, probably be better to times it because then it'd be easier.
Yeah, optional, but I would multiply it if it was a fraction. Here, what do I need to be careful of?
Take the negative to both.
Okay, we've got a negative 35 there, so you're multiplying everything by negative 35. Easy to make a really silly mistake here, which can cost you a whole mark. How am I going to leave my answer
With x is positive.
for this question?
X is positive.
Okay, so you're saying in general form, move everything across. I can definitely do that. What's my other option?
Add 10, so it could be y equals.
Okay, or my y equals mx plus c gradient intercept form. And that's what I'm going to do for this one. But if you left it in general form, that would also be fine. That would be great. Okay, 80 minus 35x is the same thing. Okay, so go and have a go at the quiz. And then I'll follow behind you. And then we're going to look at, oh sorry, so it's not on 2 slides for you, I've just spaced it out. Yeah. Oh, and I changed, thanks Lachlan, I changed this one, I put the 4 there, didn't I? Yeah. So team, I've just put a power of 4 there on this one because I just wanted to make it a bit trickier. What situation do you have in 1A? It's a product, so you're going to need to use the product rule, whereas the question I had before, you could just expand and it comes out pretty nicely. So notice that I've added in a power of 4 there. Okay, so I've changed the question. So start, once you've identified it as a product, identify U, identify V. like that. Yeah, I do recommend that. Write a list of U and V. Differentiate.
Which one goes first?
You should have your.
Which one should we go first? Is you or the beta goes first?
So you need to use the formula that's on your formula sheet because that's what's going to be available to you in a test, right? So I'm not going to tell you what comes first. You need to look. Have you got a formula sheet? I've also just written it on the board. Okay. Don't be sorry. Okay. But you want to be using your formula sheet. You should have it out and be working with it. I've got a few mini formula sheets if anyone wants a spare one. Haven't got enough for everywhere right now. You want to be familiar with your formula sheet. Sure. Alrighty, so
Why does yours have 4?
yeah, because Sam, I mentioned that I've added that in to make the question a bit trickier.
Should we add that in?
Yes. Okay, so multiply by the power for the chain rule. Multiply by the power. Differentiate what's inside the bracket.
Oh, I could be starting scissors.
Keep the bracket the same, but reduce the power by 1. Then follow your formula. U. Remember, anything with more than one term, group in brackets. Times dv on dx. So it probably would have been helpful if I'd written these like this. Okay, now that that's on the formula sheet. So dv on dx. Plus v times du on dx. I'm just going to pop the du on dx out the front. Okay. Okay. What are we going to need to do now? We're not going to expand.
Oh, we could expand the first part of the...
I can see why you would think that, Ryan, but I wouldn't expand it in this situation. Yeah, we're going to factorize. Now, it can be difficult to identify that that's what you need to do here, but you will find this happens pretty much every time you have a product rule that has a chain rule that you've used. Okay, so this situation will come up a lot. That's why I wanted to change this question so that we could do this again. So start looking at the easier things, okay? So look at the term out the front of those brackets, okay? What can we take out from both of those? What's common? 4, okay? Now go and have a look at what else is common. What else can we take out? Okay, so the bracket's the same, and we can take it out to the smallest power. Okay, so people were saying to the power of 3. Yeah? Okay, so now you can help to draw a square bracket. It doesn't matter. You might end up with some other brackets in there. Let's have a look. For the first one, we've taken out 4. That came from here. So what are we left with here? 10x to the 4. Okay? Now, what's happened with this 4x plus 1? Have we taken that out? No. So we need to keep that here. Okay? What's happened to this? Okay, that's been taken out. So we're all good now. Next term, we've taken out 4. So, okay, so what do you want me to write, Luke? And how do I join that? Plus. Okay, beautiful. Okay, so we're almost there. What are we going to need to do now? What are we going to need to do now? Yeah, we'll need to expand. Now, because it becomes quite laborious, it may be helpful to do a sneaky little above, okay? So that we can then simplify that in the next step. Saves us a bit of writing, okay? Just make sure you're very clear with what you do. So I'm keeping the 4, the 2x to the 5 plus 1 cubed. And now I've got 40x to the 5 plus 2x to the 5, 42x to the 5, plus 10x to the 4 plus 1. It comes out really nicely. I'm sorry about the space, by the way. Okay. That's what we're leaving it as. Okay, this is fully factorized because there are no addition or subtractions between the brackets. Whereas up here we had this was our problem. Okay. It can feel quite difficult, but it's pretty much the same idea each time. So as you practice, you'll get the hang of it, Sam.
So we'll lose a mark if we just leave our answer as the first y dash.
Yeah, that's a good question. It depends on the question and the marking scheme.
Okay.
Yeah, if this was worth 3 marks, I would for sure be doing that.
Okay.
If it's worth 2 marks, then you're a bit uncertain. If in doubt, probably should go for it.
Yep.
But this is really how you should leave your answer. Okay?
Thanks.
No worries. Okay, next one for B. How are you going to differentiate this one? Okay, it's a quotient rule, so you need to start by identifying your U, identifying your V. Okay, this one's quite nice. And then differentiating. So remember, the product and quotient rules start out the same with a list. What's U? What's V? What's du on dx? What's dv on dx? But then make sure you choose your formula correctly, okay, which is from your formula sheet. Make sure you know where that is on the formula sheet. Don't let the yearly exam be the first time you're looking at that on the formula sheet, okay? That's a bit of a fool's error. Oh, sorry, rookie error.
Yeah, I knew.
Alan just said why rookie. Don't you understand?
Do you not understand the rookie errors?
It's an Air Force
Wait, what's the
Okay, so now it's, boys, come on. It's pure substitution. So we've got V times du on dx. You might have wanted to put that out, boys, out the front at the beginning. Minus u times dv on dx over v squared. Okay, so like I've gone totally rogue here. Luke, tell me. Okay, so this is multiple terms that needs to be grouped. What else? Okay, my v squared, right? This means just the 2 is squared. So watch out, be careful. Okay? My suggestion here would actually be to put the 5 out the front. That will also help you remember to carry that negative into both terms. Okay, tell me, thank you. Are we going to expand all the brackets?
Not the bottom.
Not the bottom.
Okay, not the bottom. Why?
Because it's easy like that.
Okay, it's fully factorized. How do we know the top is not fully factorized? Because of the minus in between the brackets. Okay? Now I'm going to do my sneaky little line expanding the numerator there. Okay, notice I've circled the negative to make sure I don't make a rookie error. Okay, and now this is quite simple for me to put together. I'm looking for opportunities to factorize and cancel, but not really, okay? Usually you'll just stop at simplifying this. So we've got 20x cubed plus 12x squared plus 25. Don't go trying to factorize this. Okay. Unless it was a really simple factorization, then I wouldn't bother trying. Okay? Alrighty, so that's how we're going to leave that one. Next question, find the equation of the normal to the curve. Okay, so can you go ahead at that one? Remember, equation, write your point gradient formula and your list. The point and the gradient. It seems like I have a preference for x being 2. It seems like x is 2 in my examples. Okay, don't forget that it's the normal. Okay, so watch out for that. Can I wrap this? Anyone still need that? What? Kimberly, did I give you that? No worries. What? Okay, team, I would be shocked if in your yearly exam you were not asked to find the equation of a normal or a tangent to the curve. Haven't seen the paper. It's not, we don't have the paper yet. I would be shocked though, right? This is one of the key skills that we've learned. Remember, if you get stuck or you start psyching yourself out, do something that you know how to do. So even if you know you're not getting the answer, at least differentiate if you know you need to differentiate, or do as much as you can all the time. Okay, hopefully we'll actually be able to get our solution. So I'm hoping that you've got the y value of your point. Sorry, Alicia. What did I do? In here. So, oh, sorry, thank you. So that's going to be 5 there. Thanks, Alicia. Either is fine. My preference would be if I've got a fractional gradient, I'll multiply and then I'll end up with general form. If I've got an integer, a whole number gradient, then I would just expand and get y-intercept form, gradient intercept form. But either will be fine always. unless the question specifies.
Yes.
Okay. What do I do now?
I thought you
Year
were supposed to
11.
factorize.
I like
So I don't need to factorize.
I thought like before you went to factorize.
It's 9.
No, I don't need to factorize. My goal is, thank you, year 11. My goal is to find the gradient of the normal to the curve. I'm starting by finding the gradient of the tangent to the curve, which is differentiating. Job.
So you can substitute x equals 2.
So I specifically want to know the gradient of the tangent at the point where x is 2. Okay? And I come up with 9.
And then reverse.
Okay, so my gradient then of my normal is going to be negative 1 over 9. Okay, and now I'm going to go and find the equation of my normal. Okay. You're welcome. You're welcome to expand the negative 1 over 9 and answer in gradient intercept form. I will multiply through by 9. Okay.
45.
45 instead of
45.
Okay, so make sure that when you multiply, you're multiplying by the entire side, okay? And now watch out because that's going to both terms, yeah? This game's gonna go, but it will never stop. Okay, watch out. Negative 1 times negative 2 is positive 2. There are so many places in an exam where you can make mistakes with negatives, right? So I want to bring it to your attention all the time, and hopefully we'll be watching out for it. Which side am I going to?
Left.
Okay, to the left because I want
Positive x.
x to be positive. Okay, team, can I just say, this is a little bit devastating when this happens. And as a marker, this puts me in this 3-mark question in a difficult position. Can you see the difficult position you put me in when this happens, right? Am I really trying to test, do you know what negative 45 take away 2 is? No. But you still got the answer wrong, right? And so you put me in a difficult position. We need to take care, okay? Look, usually I'm going to give you that mark anyway. If it occurs repeatedly, then I won't, okay? Because you do need to take care. But do watch out. You've got a calculator, use it, be careful. Okay, so that was really a not so quick quiz, wasn't it? What we're looking at today, sorry team, I'm just going to ask that we're quiet unless we're contributing because it's disruptive. You don't need to tell each other to be quiet. I've said it, that's enough, okay? If you can't contain your discussion, then please take it outside so we're not disrupted by it. Okay. Question 1. This says describe the gradient of each curve. What we're going to do is this. We're going to put some little labels on there. Are you happy with this? The gradient is negative. Yeah? Because the curve is going downhill. What happens here? Like it's already marked on there for this one. What happens at the vertex? It's stationary, so the gradient is 0. And if we look at that tangent there, you can see it's a horizontal line which has a gradient of 0. And then what happens as we start going back up? The gradient is now... Okay. Alrighty, this one here. I'm starting from the left. Tell me about the gradient. It's positive because the curve is going uphill. It's increasing. And then when I get to here, it is 0. If I drew a tangent at that point, it's a horizontal line, and the gradient of a horizontal line is 0. Okay? And then over here, we're going downhill, so we've got a negative gradient. Okay? Can you do that on C?
Sorry.
And then I'll follow behind you.
So we have to start from left to right.
It doesn't matter. I mean, the gradient is still the same whether you're moving right to left.
Is it?
Yes.
What if
So
you're
if
moving-
you
if you're
move this
moving
way,
down?
that's still that doesn't
Oh.
change that this is a negative gradient. I mean, it makes it maybe harder to think about.
Yeah. It's a nice pen.
Okay. Are we happy with this? Does that mean that people are going? Or? Okay. Well. Okay. We happy with this?
Yep.
All right. Next one. This question's different, so don't draw that on there. Okay. What we've been asked to do here. Just waiting. Go and stand outside, Sam. I asked for quiet. You don't need to make comments to Ryan. Go stand outside. Okay? So, we're sketching the gradient curve. Okay? So, you know when you have y equals x squared and the gradient is 2x? Yeah? The gradient curve would be a bit of a dodgy graph. The graph y equals 2x. Okay? So we're sketching that, but we don't actually have the equation here. Okay? So what's going to happen is when we sketch this, our y-axis is going to be our y-dash axis. Okay? So when I'm going to draw it on top of this graph. That's actually going to be the gradient axis. We still label it as y, okay? But it's really the y-dash or the m axis. Okay? Now, I'm going to have a look at this curve. I'm going to put things on here. Don't put this on for now because I'm going to rub them out and you can't do that easily. Okay? So I'm just going to label like I did before. Don't do this, okay? It'll make your diagram messy. Okay, so I think we're okay with this, right? So, notice the points where the gradient is 0, okay? If this is my gradient axis now, I'm going to mark that my gradient is 0. Does that make sense? So if my gradient is 0, where's 0 on the gradient axis? It's here, okay? And then however far across I am, okay? Now, what's going to happen is my graph's going to be super, super dodgy, okay? It's going to be super dodgy. It's just going to be an idea. I don't know how far to take my curve or exactly where it's turning around. That's okay, all right? But what's going to happen is my curve has to go through 0, and then it's got to come back up and come through 0 again, and then go back down and come through 0 again. Or maybe it's gone down and up, and I don't know which way, okay? I have to work that out. So I have a look, and I see here that the gradient is negative, okay? It's quite disconcerting to draw the gradient graphs, okay? Because you're thinking going downhill, but that's not what it means when you're graphing the gradient, okay? So that means your gradient is negative. Here's my gradient axis, and this is where my gradient axis is negative. Does that make sense? Okay? So my line has to be down here. A negative gradient means it will be below the x-axis. Can someone go and get Sam back, please? Thanks, Ashley. Okay. Now, my gradient is positive. Are we happy with that? Okay. A positive gradient is going to be above the x-axis. So this is where my gradient on that axis is positive, because these are all my positive numbers. Yeah?
Is that curve? Or
So yeah, it's going to curve. So how do I know where it curves? Don't be too stressed. Just know that you need to come back to 0, okay? And so I just do something like this, okay?
just draw the lines.
Boys, no banter between you. You don't need to tell each other to be quiet.
We just told him what to do.
We tell him what to do.
Why did I hear?
He was drawing the negative.
And we just told him to draw the lines.
Alright, thank you. So, now what we're looking at is the gradient is negative, okay, until we get to here. Remember, this is the gradient axis, and the negative numbers are down here. So it means it's down here, but am I going to do this?
No, there's another
Because
one.
I know I need to come back. So if I put those zeros on, they really help me draw this, okay? So I know I need to come back. So I don't know how far to go down. Don't stress about it. Just loop it, okay? And then now I've got a positive gradient, which means on my gradient axis I need to be above the x-axis, right? Because they're positive numbers, okay? So the confusing thing is that you're graphing a positive gradient, but that's not necessarily looking like a positive gradient because it means positive here rather than a line that's sloping.
It's decreasing in its value, the gradient.
Yeah, so it's increasing and decreasing. So here you've got it's positive, it increases and then it decreases because it starts to flatten out as it gets to 0, right?
You can't have normal Cartesian plane there's positive y and negative and positive x as well.
Yeah.
Is this just positive like y's because it's not?
It's
Or
the
is it
same.
still
So
like-
this is here is where your gradient is positive, and here is where your gradient is negative.
But it doesn't have 4 different parts like in normal Cartesian plane.
Yeah, it does because x is positive over here and
Oh,
x is
okay.
negative over here. Yeah.
How do you know where to start with negative? How do you know to do that?
Yeah, good question. Hopefully I'll answer that for you in the next one, bench.
Okay.
Okay? So, I would identify the turning points to start with. Okay, so this would be my first step. This is a turning point. The gradient is 0. The gradient is 0. Okay? I know now that this is going to look like a parabola. Okay? My question is it a concave up or concave down parabola? So I look over here and I see I have a positive gradient because it's going uphill. Remember, this is where my gradient axis is on my gradient curve. So a positive gradient is up here. These are all the positive numbers. So it needs to start up here. Now, if I need to start up here and go through this, then I'm going to be going like that. Yeah? And then I know I'm going to have to bounce back and go up. But we can see this is a negative gradient. It's going downhill, and that makes sense because I'm in the negatives on the y-axis, which is my gradient axis. And then we see the gradient is positive, and I'm now in the positives for my gradient. Okay. Another helpful thing to think is this is going to be a cubic, right? Because it's got 3 intercepts. Also because it looks like your normal cubic but with some bumps in the way. If you have your most basic cubic and you differentiate it, you come up with a parabola. So I expect a parabola, okay? This one here appears to be a quartic, so it's going up at both ends, okay? And it's got some bumps in between. If I differentiate a basic quartic, Dan, I'm not sure what you're saying, but it's unnecessary at the time, okay? That's going to end up with a cubic, and you can see here I've got a cubic that's got some bumps along the way. If you differentiate a parabola, you get a, is that over there? Straight line, so your gradient will look like a straight line. So you can kind of use that to help as well. This can be a little bit tricky, okay? Yes.
So I'm just confused. How do we know what to sketch if we don't have the equation with us to get the differentiation?
Well, that's what we've done.
Sorry?
That's what we've just
No,
done.
I
We
know.
didn't have the equation.
I just missed the part where we know how it's compared up.
Oh, so I looked at, this is a positive gradient on the curve.
Yeah.
And here's my gradient axis. These are the positive numbers on my gradient axis. So I need to be up here when I start. So I need to be up here, but I know I need to come down through there. So that told me to go like that. Okay? Alrighty. So